Last time I introduced you to the best fitting line, and we basically said that this best fitting line is drawn in such a way that we want to make these dots here, on average, as close as possible to this line, on average. All right. Now, when we say we want to make these dots as close as possible, we're not rearranging the dots, right? We're rearranging our line. We can't move our data, but we can move this line. All right. And what we're trying to do is minimize the average distance these points are to the line, and it's specifically the average vertical distance. So how far, this dot here is to the line vertically. Same thing, how far this dot here is to the line vertically. All right. So what the best fitting line is doing, which is, by the way, also called the regression line, what it's doing is it's minimizing, it's been drawn in such a way to minimize the average vertical distance the points are to the line. And you don't draw this line, using the eyeball method. There's an actual mathematical formula that I'm going to show you in a minute that we use to draw the line. Okay, so there's math involved. But not that you have to do much math, but I just want you to know what's important to recognize is that you don't freehand draw the line. There's an actual formula that is used to draw this line. All right, so this would be the regression line for this set of data, okay? So obviously some of the points are going to be close to the line and others are not so close, but on average, if we calculated the average vertical distance that points are to the line, that number would be as small as we can get it, okay? Now contrast this with this line here. This would not be the best fitting line. Why? Well, it made these three dots pretty happy, but it missed all of these. In fact, if we were to calculate the average distance that these points are to the line, we would get a larger answer here than over here. Remember, as long as you use the formula for the regression line, it will absolutely positively be the case that this line has been drawn to minimize the vertical distance points are to the line, if you use the formula correctly. If you use it incorrectly, or you draw freehand, and you get some other line, then I guarantee you the average distance points are to the line is going to be larger. This is no longer the best fitting line, which means if you tried to use this line to make predictions, your predictions would be worse than if you use the best fitting line. So we are always going to use the best fitting line to make predictions. And remember, the best fitting line is the regression line. Okay? So another way of thinking about this is that if we use the best fitting line, what that line is doing is it's minimizing the average scatter around the line. The average scatter. Now, I can't reinforce this enough. You're not moving the dots around. That's called manipulating your data or fudging your data. That is a cardinal sin when we do research. Okay, you never change your data by just erasing and making the number higher or lower. So these data points, they represent your XY data. You don't change those. All right. What the regression line does is it shifts around until it finds the line of best fit. In other words, that line now has minimized the average amount of scatter around the line. It's going to be as small as it possibly can be. And here we can see a lot of scatter off the line. This line has not minimized it. So there's no way we use the formula correctly here. So here, average error is minimized. Here, average error is not minimized.